Good day, everyone. Thank you for joining us today for our demo of Everybody Needs a Little, well, sometimes you only need a little bit of Materialize. I'm Brian Linhart on our go-to-market team here at Materialize. Some of you may have been expecting Jessica, our head of product. She was called away unexpectedly. She'll be on our next version of the demo if you want to catch her. But I'll be running you, helping run the demo today. A couple housekeeping notes before we start. This demo will be recorded. You'll be able to access it after the fact, and we'll send you an email. And if you have any questions and we have time, please feel free to put your questions in the chat. So I'm going to introduce my co-presenter for the demo today, Josh Ehrenberg. Josh, do you want to introduce yourself real quick?
Sure. Thanks, Brian. Yeah, I'm Josh Ehrenberg. I am on the field engineering team here at Materialize. Before that, I was the head of data at a company called Datalot that was Materialize's very first customer. So I've been both a data practitioner, an engineering lead, and now happy to be here and demonstrating Materialize for you today.
Awesome. Thanks, Josh. So from a agenda perspective, I'm going to go through a couple slides with you all. Not a lot of marketing, just around what we're doing here at Materialize, the market we're trying to serve, etc. So you give a little context and the architecture, and then we'll jump right into the demo. So let's jump right in today. So what we've seen here at Materialize over the last number of years, and I live this as well, I spent a lot of the last 5 years over at Snowflake, is that analytical warehouses have been great, and they're still great, right? From shared disk to shared nothing to cloud data warehouse natively taking advantage of the underlying benefits of cloud technologies, analytic warehouses have provided tons of value to the business, and they'll continue to do so. But what we've seen in the market over the last few years is a shifting. And that shifting is companies starting to need to derive value from their data in a more near real time. And with that becomes the need to have a new set of capabilities to accomplish those goals. And what we're doing at Materialize is providing a purpose-built platform in the cloud to help customers act on data right away. And that's what we consider operational data, right? And to explain that a little more, I wanted to show you this kind of image here and what we consider analytical data and operational data and how they have different requirements, right? If you look at the blue part of the graph here, that's where a data lake or a traditional data warehouse would use. That's data from the foundation of your business, from the beginning of time up to sometime maybe in the last day, right? Someone sitting at a computer, looking at a report, running a traditional analytics workflow, right? But this growing area, and the area we're focused on, is this kind of pinker or redder area here for operational data. And that's the data that really lives in the last few minutes to sometime in the last day. It's potentially a smaller subset of data, but it's just as important or more important, and it needs a different kind of performance and workload profile. And from a platform perspective, a different number of requirements, right? So today, if I want to service that operational requirement, we've seen customers and companies do it two ways, which is using their traditional or cloud data warehouse to service those operational data workloads, or use a more modern stream processor technology to do so, right? And both can kind of work, but both come with compromises, right? On the left side, when you're doing traditional and cloud data warehouses, those systems are generally batch-based systems. They're not built for high concurrency, low latency. They're super easy to use, but the architecture is not there to support what you need to do to get near real time. When you increase the freshness or the recency of data that you're driving, it costs a lot more because you're rerunning the compute more often and at larger sizes to accomplish that as close to near real time as possible, right? So those are the compromises there. On the stream processor side, these are more modern technologies that are dedicated to more streaming technologies. They work as well, but they're very complex. They create brittle infrastructure that doesn't scale over time. And as we call ourselves the operational data warehouse, that is primarily because warehouse implies multiple data sources, right? One of the challenges with stream architectures is they're specific to a specific stream, right? We are able to provide a platform that services multiple data sources and still provides that kind of stream processing technology. And, you know, these stream processors, it becomes very expensive, maybe not from a compute perspective, but from a people perspective and a process perspective, right? So those have been the two ways to do it up to this point. So what are the three things that we here at Materialize believe are the cornerstones for an operational data warehouse? Those things are freshness, responsiveness, and consistency. We feel like unless you have all three, you can't suitably service these workloads for operational data work. You can get some of these features if you use these microservices, stream processors, traditional analytical data warehouses, but you can't get all three. And what we're bringing to market, and we'll show you here today, is that we're providing all three to our customers as an operational data warehouse, as Materialize. And what kind of things are we servicing? What we're servicing is both new use cases that you can see here, things like feature serving, dynamic pricing, notifications, transactional communication on the factory floor, but also more value from current use cases, right? Think of something like fraud detection. If I can detect fraud in an hour today with my traditional data warehouse, but I can shrink that down to seconds, how much money can I save my business in detecting that fraud sooner, right? So when time matters and time means money to your business, operational workloads and operational data warehouses become that much more important, right? So just briefly to talk about the architecture, to give you some sort of context as kind of Josh goes through the demo today. If you're familiar with any sort of modern analytical data warehouse or cloud data warehouse, this will probably look familiar to you, right? We have a three-layered architecture with a separation of compute and storage and a control plane at the top. When you talk about the bottom layer, we have persistent storage on S3 on the back end, with data being driven in real time from either Kafka, PostgreSQL, or PostgreSQL compatible, or any sort of SaaS data sources from webhooks. It lands in the persistent storage layer, and then where the magic happens to Materialize, it's powered from our frameworks of differential data flow and timely data flow, is in the compute layer. This is where we're doing all of our materialized views and in-memory indexes that are providing incremental view maintenance, which Josh will talk about, and a lot of the value that makes it fast and cheap as well, or cheaper than doing it alternatively. On the top layer, on the SQL control plane, we're fully ANSI SQL compliant. So your analysts, your people using dbt or anything else, other normal tools that speak SQL, can speak right into Materialize, run queries. And one of the cool features that Josh will talk about as well is a subscribe feature where we can provide real-time alerting and notifications to other machines, other devices, or end users if something goes wrong in real time, right? We'll talk about this in a second, where we believe we fit in the overall modern data stack, but we can also sync data out, right? We're not a traditional analytical data warehouse, so moving data out after it's transformed to Materialize, et cetera, is something that customers may want to do, and they can sync it out from Materialize as well. So the last piece of the architecture I wanted to touch on is kind of some of the magic we talked about in that compute layer, powered by that timely data flow and differential data flow, which is this move from batch computation to incremental computation, right? As you can see here on the left, a traditional database will lay down the data and then users will interact with it via a query engine, right? And as you need to do work more often or data changes more often, that query engine will just run more, which means more cost, right? More resource on a consumption-based model, which we're a consumption-based model as well, we'll call for increased cost. On Materialize, we flip that on its head. We move the stream processor to the front, and we lay down the data in the way via materialized views and indexes that you want to consume it in advance with that incremental view maintenance. What batch to incremental means is less compute cycles, less work the system's doing, and less cost to the end user for better performance, right? So kind of that magic of Materialize. Where we believe we fit in this modern data ecosystem is, as you can see here, kind of right in the middle, right? Like from a relational database or generated SaaS data, dropping data into Materialize for these operational workloads, and then syncing that data out back to your traditional data warehouse. Now, we also don't believe, and we know that not all workloads and not all companies have a need for a vast array of these operational data workloads. So we do think there's a place for those still in the environment, and a lot of customers will be dropping data directly into those environments. It doesn't all need to flow through Materialize either, right? So we believe that this is an important enough area for customers and for companies that they'll want a specific tool to put in the stack to service these operational workloads. So that all being said, hopefully that gives you a idea of what we're doing here at Materialize, the area we're trying to service. And I'm going to hand it back over to Josh, and he's going to take us through the demo today.
Great. Thanks so much, Brian. All right. Hello. So you've just gotten a great intro from Brian about what Materialize is, what the architecture looks like. So we're going to now see how it works in practice to keep your data, your operational data fresh. Um, so, uh, so for today, we've talked a lot over time about how well Materialize scales up horizontally to really big workloads. And complex architectures. But one thing that gets missed sometimes is it also scales down really well. So that's what we want to talk about today. I want to show you how efficient and easy Materialize can be for smaller businesses or businesses with only a targeted need for real-time data. So our goal today will be a full end-to-end deployment of Materialize in around 20 minutes. So there are tons of examples of situations where an organization doesn't need a lot in real time, but maybe just have a few things that would be really useful to be able to keep fresh. Maybe an analytic they'd like to use as a source of alerting or a source of automation. And so that's what we're going to look at. For today's example, we're going to imagine that we're managing a chain of 3 retail stores, and our use case is going to be as follows. We found that it would be very impactful to be able to compare our incoming revenue over the course of the day, right, versus an average of the last 2 weeks of revenue. This is going to allow us to see how we're trending compared to the average over the course of the day and respond immediately if something is going badly at one of our stores. And we're going to achieve this with 2 SQL queries and a simple dashboard visualization. In addition, we would also like to implement an alert if one of our stores stops booking revenue for more than 15 seconds, since it would indicate something going wrong at that store, and we'd want to be alerted about it, even if we didn't happen to be looking at our dashboard at the time. So that's what we're going to look at today. The slide that Brian has up here are going to be the steps that we're going to take to implement that over Postgres and Materialize. And to create a pipeline of changes that we can incrementally compute analytics on and build further event-driven services and real-time visualizations downstream. And it's this ability to accurately maintain these analytics each time the data in our database changes that's the core of the value provided by Materialize and enabled by our timely data flow internals. All right, so I'm going to share my screen now. You should see infinity. Okay, we're only going to do one step from a command line today, and that is just to enable our Postgres database to replicate data to Materialize. So in order to do that, here, we're going to, let's go back to our very first, okay. We're using 2 tables today. So I've issued 2 commands here just to turn on full replication for our sales and store table. That's going to allow the transaction log to get all the data we need for replication. And then the next step here is to create a publication. Publication is just going to be how we refer to this replication. We're going to call it Materialize, and that's going to be what Materialize connects to for the replication of the sales and the store tables. And that's it. We're done. We have enabled this Postgres database to share data with Materialize. All the rest of our steps today are going to be from the Materialize console and from Grafana. So let's take a look at the console next. Now, as it turns out, there's a bunch of exciting new functionality in here that we're going to be able to make use of today. The very first thing we're going to do is create a connection. A Materialize connection just defines how Materialize can connect to our data sources. And right now, the 2 biggest data sources in Materialize are Postgres and Kafka. Obviously, for our demo today, we're using Postgres because that's where our transactions are. And we support direct change data capture from Postgres, so we don't need any other infrastructure just beyond our Postgres database and Materialize. So we'll create a new connection of type Postgres. We'll just call it Postgres connection. And schema just refers to where in the Materialize object schema this is going to go. So we can create as many schemas as we want. I've created one called Postgres, and we'll put our connection information there. The host name is just the host name as it came from. This is from RDS, from AWS. So we'll just put the host name in here. Our database, as we saw earlier, is called Materialize, and standard Postgres port 5432. The user, we're going to use the standard Postgres user. You'd probably want to create a dedicated user for Materialize in the real world, but we'll just use the standard one. You can save passwords in Materialize securely. So I've already saved my password for the Postgres user, but if you need to stick a secure password in here, you do it right here. And then we're going to require SSL for this connection. And I'm going to click here on create connection, and that's done. So we haven't actually made a connection to the database yet. All we've done is informed Materialize how to connect. So in order to create a data source, we're going to create a source, a Materialize source, which is where we tell Materialize which tables to capture from our upstream database and designate some Materialize resources to perform the continual task of pulling in data every time there's a change to one of those tables. So now I'm going to create a source here. It's already pre-populated the Postgres connection that we just created, and we'll call this Postgres source. Again, we'll put it in our Postgres schema in our data model here. And here, this is a cluster. So this is the concept, much like a warehouse in Snowflake or something like that. This is where our compute resources live. They come in t-shirt sizes. Today, we're using a 3x small, which is the smallest clusters offered by Materialize. They represent fractional CPUs. So, like we said, scaling down very effectively. Obviously, you wouldn't be able to do this if you're standing up your own infrastructure. Publication, this is what we created in the first step. We called our publication Materialize. And now we'll just, which tables out of the publication do we want? We're taking sales, and we're taking store. So now I'm going to click on create source here, and you can see already, okay, so that has created, and in the background here, it's starting up that cluster, and now you see it's running. It is already pulling all the data from those tables into Materialize, and we'll start keeping up to date with any changes made in that database. So all our connectivity is done. If this was a big enterprise deployment, we would probably be using, security features like Bastion hosts or AWS Private Link, and we have all of those options. We can do these steps with Terraform, all the things to make it battle hardened and all. But today our fictional company today is a small company. We're doing things from the console. It's just us. So we're up and running here. We're getting data. Okay, so we've created our sources, and we can see in the console that they've come up cleanly. It's pulling in our data. The next thing we're going to do is actually write our analytics. And now for that, we're going to use the new SQL shell in Materialize. Actually, in the background, our built-in SQL shell is just a Postgres client. Okay, so you don't have to use our SQL shell. You can use pSQL or whatever your favorite database client is. As long as it can talk to Postgres, it can almost always talk to Materialize. And now we're going to connect to our cluster. So the next step is, since we're using the Postgres schema, I'm going to set our cluster to compute and our schema to Postgres for this session. That's done. Now we are, for the rest of this session, talking to that schema and cluster. And let's build our first analytic. Here's what that's going to look like. Oops. This one's called Today's Sales. this is going to be the query for graphing the sales from today. So as you can see, we've got an inner CTE here that's going against our sales table, extracting the store ID, the hour, the minute, and the sum of the cost, which is going to be revenue. And we have a group by over the store ID, hour, and minute. So basically, we're summing up all the data by minute here. And you can see there's a time filter that's going to select for today's date. So that means we have a 1-day window, and that will flip at minute every day. Because these queries run continuously, right? So we're constantly evaluating that time window, and it will, as soon as the day flips, this will automatically flip, right? The outer query here, it's what we are doing is joining our CTE to itself. We are doing that so that we can do a cumulative sum, right? We want each 1 minute data point to be the sum of the previous minute and that minute, so that we can see sort of an increasing line over the course of the day as our daily revenue accumulates, right? So we're joining it to itself, and that's worth calling out because I think joins are really one of Materialize's superpowers. Very tricky to do well in a lot of streaming frameworks. It's a hard problem. Timely data flow ensures that our joins are not only easy to do, but consistent, because there is a timestamp associated with each data point. We can ensure that our joins are consistent. In fact, we support strict serializability. This means that you can safely write these queries for financial transactions and be sure that you're never going to create a data point that's inconsistent at any point in time. It will always be consistent with the most up-to-date available information. So that's what we're doing here. We're joining it to itself. We're grouping by the store ID, the hour, and the minute to create our data points. And that's done. We've created our view. Now, in Materialize, all we've done is put this SQL into our schema, into our objects, under this name, under today's sales. It's not actually running this yet. So what we want to tell Materialize next is, that view that we just created, we would like that view to run continuously and maintain data each time it changes. And to do that, we need an index. And what an index tells Materialize is simply that. We're going to run this view continuously on a cluster, incrementally update it, and it's going to index that data on these 3 fields, on store ID, hour, minute. That means that if we query now Materialize, and let's do that, our index is created, as easy as that. Now, if we perform a query on this view with these 3 fields in the where clause, it's a point lookup against this index, and it's going to return in milliseconds. So that's important to realize, and this data is now being maintained. All right, so that's today's data done. Now we need our weekly average. This query looks very much the same. The only difference is we're dealing with multiple days now, so we're extracting the date as well as the hour and minute. And we've got here now a 14-day window, right? And then outside of that, we have another CTE, which is again doing the self-join so that we can get our cumulative data. So this is creating 14 days worth of cumulative data points. And then in our last CTE, we're just averaging by day. So what we really want is 1 day's worth of data points that are an average of each of those. So because we're going to be comparing today's data to the average of the last 14 days. So we're going to average on the outer CTE here. And that's done. That view is created. And just like before, we'll create an index on store ID, hour, and minute. And now that is being maintained as well in Materialize. Okay, so we're almost done here. This last one is just for our own convenience in building the graph. I'm going to build a combined view here that just joins these two indexes or these 2 views that we just created. We're going to join on we're going to join on the store ID hour and minute to make these easy to graph against each other. And that's done. And of course, just like before, we're going to create an index. This time, we're just going to index on store ID, right? Because here you see we're using, these are the 3 fields that we built our previous indexes on. So you get point lookups here. And again, when we look this up from our graph, we're going to look it up by store ID. So that's what we'll index on. And now that's running. We're done building our queries for now. So for the next step, I just want to move over to Grafana, and we're going to build our dashboard. I'm just using Grafana Cloud because it's easy, but you can use any Grafana for this. We're going to create a new dashboard and add a visualization to it. You can see here I've pre-created my connection, but one thing you'll notice is this is a standard Postgres connection. This is a theme with Materialize. Since we're Postgres wire compatible and we use Postgres query syntax, one of the most common integrations out there in the world. Lots and lots of tools can speak Postgres. This is no exception. And lots of times we can just, any tool that can talk to Postgres can oftentimes talk to Materialize. And so that's what we're doing here. We're going to use this connection. If I was going to create that connection, I could just come here to this external tools. Here's all the stuff that populates that connection, right? So now let's create a data panel. We'll just go straight to code here. Here's what my query is going to look like. You'll see how simple this is. I'm just creating a Grafana style timestamp here, and then pulling my 2 fields, my average cumulative revenue and today's cumulative revenue, from the combined view. And this graph is going to be for store ID 1. So you remember how I said we were going to look up by store ID? Here's the where clause for the store ID, and that's what we've indexed on. So this will be very performant. And we'll call our view store 1. We'll apply this and make it nice and big here, refresh, and bang, just like that. Here's store 1. And for the rest of our visualization, I'm going to come here, duplicate this, and we'll edit it and make this graph for store 2. Apply, and then here, duplicate, edit, store 3. All right, let's refresh all of this. And as promised, here's our 3 graphs in a visualization. And now we're looking at 6 hours here. I could zoom in on the last 15 minutes here. You can see this is right up to the minute here. We're getting data points. And one thing, immediately we're getting some signal here about how our stores are doing. We can see store 1 is doing the worst today. It's got there's a meaningful gap between the average revenue and today's revenue. It looks like store 2 is doing a little bit better at some points, although it's now looking pretty much like store 1. And then store 3 is crushing it today, coming in way above the average. So if I'm managing my chain of stores here now, I've got a very good up to the minute idea of what my stores are doing. And by the way, we've set this all up in 20 minutes, and we're doing it on a fraction of a CPU on the Materialize side. So no additional infrastructure for you to spin up, no operations, nothing like that. So, but we did promise one more thing. We promised that we're going to do an alert if the revenue stops flowing. So let's do that next. In order to do that, we'll go back to the console here, to our SQL shell, right? And we'll make sure we're in our Postgres, not cluster, in our Postgres schema. Okay, and now we're going to create one more very simple query. This is just a view of all the sales transactions in the last 15 seconds. All this is saying is get everything out of the sales table that was created in the last 15 seconds. And just like before, we'll create an index on that by store ID, right? And now that's being maintained by Materialize. So I can now query just the transactions by store in the last 15 seconds. That, but in order to create an alert on this, we're going to, whatever we're using for our alert service downstream that's going to handle our paging or our Slack messages or whatever, can create a long-lived Postgres connection to Materialize to get this information. And we call this a subscribe. So here's the syntax for that. Basically, we're just saying, subscribe to this select query. And the select query is count the number of sales transactions from the 15-second view, where, remember, we indexed by store ID. So this is the alert for store 1. Let's take a look at it. This, now you'll notice this is changing. This is telling us how many transactions we've seen in the last 15 seconds. And we're seeing that number going up and down based on what the query is returning. But you can see this is happening in real time. And if I was going to, I could just tell my alerting system, hey, if this count ever goes down to 0, that's an alert. So let's make that happen. Let's break something here. I'm going to go here to, this is my service that's generating the data into my Postgres database, and I'm just going to stop that. And if we flip back here, we'll watch our count go down for the last 15 seconds. And just like that, our count hits 0. And now we're in an alert condition. Now we can be paging people out and saying something is down at store 1. And assuming that that gets fixed and we start generating transactions again, immediately we'll see this subscription start to reflect the fact that there is data in the last 15-second window. And so with that, that concludes my demo for today. We've shown how in only a few minutes, we've gone from a standard Postgres transactional database to having streaming, real-time visualizations and alerting on our key operational metrics using Materialize and fractional amount of compute. So, a very economical way to expose just these key operational metrics. All right. Thanks very much.
Josh, thanks. There's one question. I know we're over time, but just to clarify here, someone asked, what sources do we work with outside of Postgres? Do you want to answer that real quick before we wrap?
Yeah, absolutely. Let me figure out how to stop sharing here. Okay, I'll just go back to here. Yes, so today there are 3 main source types. One is we obviously support CDC from Postgres. The next is Kafka. And because we can, you can pipe in just any kind of data into Kafka. So lots of people use a CDC like Debezium or something like that to post, for MySQL data or, Oracle or SQL Server or that type of thing. And we're in the process of building more direct CDC connections from Materialize. So you'll see the choices go up there. But in the meantime, we can use Kafka as an intermediary for a lot of those things. And then the third thing is we just released support for webhooks. So that works really well for a lot of sort of out-of-the-box SaaS solutions, things like, things that are coming over from like AWS or, lots of SaaS services provide webhook interfaces. And so typically that's good enrichment data. So those are the 3 main sources today, but watch that space because there are plans to really increase the number of direct CDC solutions into Materialize.
Angel has a question. One last question. I know we're over, but Angel has a question in the chat. Can Materialize be used as a regular OLAP data warehouse, or is it really only intended for operational use cases?
So up to a point, like I think what you will find is that as you start creating more of these indexes, right? It tends to, those are backed by memory. So depending on the size of your data, that tends to be, what's economical to maintain in real time in Materialize. Now that said, You can also run queries off of disk in Materialize. And oftentimes, if you only, if I would say, if you don't have huge requirements for data warehouse, it would be possible to do in Materialize. Although I think lots of times you might outgrow those capabilities pretty quickly and want something else for your OLAP stuff. I don't know if that'll always be the case, but today Materialize is very much targeted towards those operational use cases. That's where you're going to see the most bang for your buck.
Great, thank you. All right, well, I want to be cognizant of everyone's time. I know we're over by a few minutes. Angel, we will follow up with you with your extra question there around transformations on DBT. We interface with DBT. We'll get back to you on that one. But thanks everybody for your time. Be on the lookout for a recording of this if you want to share it. If you have any questions, feel free to reach out to the team via the website. If you want to try a trial with some playground data or even bring your own data, go to the website. You can launch a free trial. And if you have any other questions, feel free to reach out. Have a great rest of your day, and I look forward to seeing you next time. Thank you.
Thanks.